Fantastic. Thank you, Graham. You're the consummate MC. Hey, thanks everybody for setting aside time for us today. We're pleased to be back on with IWPC for another webinar with a host of partners. AWS, whom you all know, Rebaca, who you may know, is a cloud native testing provider. KX is an analytics partner for us, and ourselves at EnterpriseWeb. I'm Dave Dugal. I'm the founder and CEO of EnterpriseWeb. And later on in this call, I'll be joined by my colleague, Bill Malik, who's our Chief System Architect. So the topic today is AI-powered TestOps. And we're going to discuss and present how we can simplify, automate, and optimize for scalable telco testing operations. That's a mouthful. I think in short, to sort of summarize this, is every telco is looking for OpEx savings. And I think if there was an opportunity, not only OpEx savings, but improved IT productivity. And if there was an opportunity where you could actually leverage lower cost cloud resources, AWS calls them spot instances or reserved instances, which are often underutilized, so there's spare capacity. If you could tap that and achieve 25%, maybe 50% savings, you would. And that's about what we're going to present today. The challenge for that is that those resources are very volatile. So you really need a management platform over the top to help identify the available resources, map your test jobs to those resources, and then manage them, the end-to-end lifecycle for those tests. And so we'll be diving into that in detail. So let me go through this today. The slides, IWPC is also kind to make these slides available after, and they will also at some point post the webinar. So you don't have to take screenshots, or you can just focus on the discussion. And again, as Graham pointed out, we love to get questions. Some things we might table to the end just so we can get through a certain amount of content, but we're also happy to make this interactive. So as you guys all know, open multi-vendor networking puts strains on your testing processes and your infrastructure. And you're under pressure to do more testing faster so you can onboard innovation. But you also need to reduce costs as well. So that's the trick, right? Do more for less. AI-powered TestOps simplifies, automates, and optimizes testing operations so telcos can scale their operations, onboard innovation, and accelerate service delivery. So we're going to show how Bill, my colleague, is going to be able to act as a developer, an engineer, someone responsible for putting test jobs together. He's going to be able to talk to the network. So we're going to use a Gen AI NLP interface. And he's going to say, I want this workload with these tests. And the system's going to actually automatically identify, based on streaming data, that a feed that we get from AWS. It's going to identify across zones the optimal placement of that test job based on cost and efficiency. Once the user selects where to deploy it, the system's going to automatically deploy the test job. And then it's going to dynamically manage a distributed and parallelized test job. And this is a pretty complex trick, right? You really need a solid management over the top of that, because these are very ephemeral instances. It's a highly volatile environment. So if you want to push your test jobs in there, you need to make sure that those test jobs are being tracked and managed. If a node goes away, if a test instance goes away, you'd like to recover the state and restart it or move it somewhere else. And EnterpriseWeb can do all of that. In the end, the whole point here is to streamline and improve the end-to-end test process while lowering cost, resource, and energy costs, and improving sustainability. And sort of funny, in the age of Gen AI, we don't hear as much talk about sustainability, but I know it's still important to telcos. So it's not just about money. It's about, it's being more efficient with resources as well. So this demo, we're EnterpriseWeb, our networks.ai solution is deployed onto in AWS, and we're going to be deploying workloads into that spot instance and unused reserved instances in AWS. So our Telco product, we just rebranded it from Cloud NFV to networks.ai, the coming soon page is already up if you want to visit it, but networks.ai. So the product's been around a while. We're just sort of rebranding it for this sort of new AI era. And you can see the process that I described there, sort of AI-powered TestOps. We're going to do model-driven onboarding. We're going to do declarative composition. We're going to discover and recommend the instances. We're going to support zero-touch instantiation deployment and zero-touch management. And we're doing this with a new capability we're calling the intelligent meta scheduler. Right? For these spot instances and the reserved instances, you need to get above the layer of Kubernetes and do something a little bit more sophisticated to manage these workloads. So we're going to deploy a parallelized test job using Open5GS, which is obviously Open5G that many of you are familiar with. We're just using it because it's open source, but of course we could use this. We could test any element, and of course it doesn't have to be cloud native, but cloud native workloads work better in the cloud, and particularly in these kind of instances where they might actually go away. So you need something that is a durable workload that you can actually restart easily. And then we're going to deploy Rebaca's ABots as part of the test job, and then we're going to manage that. And we're going to be actually able to deploy that into the network, get the state and telemetry back, and manage configurations as necessary, as well as more broadly operations during the lifecycle of these test jobs. The role of the meta scheduler here is to bring order to this sort of highly volatile residual compute. Residual compute is the term that AWS uses for these sort of spare resources. So it's providing a unified interface over distributed ephemeral instances so they can be discovered and management. And it's really abstraction and automation that's making this possible, right? You need a high-level abstraction, because otherwise, if you're going to try and do this manually, do point-to-point integration and static configurations, and then try to track all of these deploy jobs on these very ephemeral instances, that's going to be, you're going to struggle to scale that operationally. And EnterpriseWeb is actually enabling that for you. So if we sort of expand what's going on here actually is, so this was what we just saw at the bottom half, and what I did is expanded to show you that our networks.ai solutions includes a harmonized standard-based telecom ontology. So we already have a rich understanding of XNFs. We have a rich understanding of what you used to call NFVI infrastructure. We know what testing is, right? We know what schemas, protocols, and formats are, and we're able to zero-touch everything using that, leveraging that model as a common source of metadata. So 100% metadata driven that enables declarative composition, programmable networking, zero-touch automation, and pervasive use of AI. You're going to see AI is being used throughout this, but you're going to notice that it's in the background. Nobody actually has to deploy the LLM, configure an LLM, train or tune an LLM. We're actually using Mixtral in this case, open source LLM. There's no training involved, no tuning involved. We're using it generically. The telecom ontology is providing the context that is optimizing the use of AI. We're also doing a lot of analytics, working with our partner KX. So Mistral over there for generative AI, KX for analytics. So we're doing sort of hybrid multi-model AI. So we're using KX as a vector-native high-speed analytics database. It does location, cost, based analytics for us. And Mixtral is obviously our LLM. But again, all that AI is going to happen in the background because we're really focused on the use case, as we believe our telco customers are. Right now, everybody's getting involved deeply in trying to learn all the details of this AI. But I think that only shows it's sort of the immature state of the market. In the end of the day, telco people want to do telco business. They want to know that it's being optimized for them. They want to know that the AI is sort of pervasively in the background, like giving them, doing detection, prediction, analytics, recommendations, etc. So completely AI powered, and then we're taking advantage of the short-lived instances, low cost, on demand from AWS to optimize that resource spend, whether it's your unused reserved instances or EC2 spot instances. And then we're using Rebaca's ABOTs as a cloud-native test platform for fast, easy deployment. It's fully programmable by EnterpriseWeb. So again, when we have we have their tests in our library. You're going to see the system actually maps the workload to the tests to create the test job, so that composition is automatic, no manual integration. And then Ebot does some sophisticated tests over the top, provides some views, and we'll show you all of that. But the whole point here is to make it as easy as possible to expedite your testing. So Bill, I'm going to pass it to you now. That was the background for everybody on the call. And Bill is actually going to take over. I'm going to stop sharing my screen, and Bill, you can go from here.
Just a moment. And let me know if you can you see my screen now?
Yes, we do.
Perfect. All right, pleasure to be talking to all of you again. I'm looking forward to taking you through the demo of what we've accomplished here with the testing solution. So as far as the setup of the demo itself, I did a number of things in advance. At Networks AI, KX, and Mixtral were already deployed into AWS. You'll see that in a moment, along with the Rebaca test framework, the ABOT test bench. All of those have been deployed in advance. I already onboarded the Open5GS test workload that we're going to be taking through the battery today. That's an easy process though, and if you look at any of our other demos, you'll see that that's a completely model-driven process, no code whatsoever to get these functions into our system. And I'll detail a little bit of that in a moment in the slides, but that's already been onboarded along with a number of 5G core related tests from the Rebaca framework. So that's already inside of the networks.ai catalog. What you're going to see in the demo itself is I'm going to log into the system and give you a little bit of background on, and I guess a little bit of detail on what was already done. And then I'll get right to design time modeling. You'll see it'll be a very easy process. It's very easy to just declaratively compose these test jobs, effectively to pick out something like an Open5GS or anything from the catalog that's already been onboarded, choose those desired tests, and basically the system will do pretty much all the rest of the work for us. It will determine the optimal placement of those workloads, and then obviously it will actually, at the runtime point, execute a management and test plan. So it will deploy the workload itself, deploy each of the tests, configure them, and then run through. And if there's any problems, a spot instance, for example, goes away, we need to migrate the workload, it will handle all that zero touch. And at the end of the day, it will just give me back my test results whenever the actual Rebaca is complete. So it'll be a pretty simple demo, and you'll see that although I'm going to be talking to it for quite a while, the amount of work that I actually have to do is very, very minimal in this kind of case. Really, it's taking advantage of all of the model-driven behavior that networks.ai is able to present and the strong partners in this demo. So just stepping back for a second, as far as I told you what was done in advance, an example was onboarding the Open5GS XNF. So what we were doing was we were provided with a set of artifacts that the system basically introspected and algorithmically mapped to that upper ontology that Dave showed a few minutes ago, which actually was able to pick out what type we had of the object, and then was able to pull out and autofill all standard-based interfaces, standards-based metadata, so properties and behaviors, etc. It was able to wrap the object that we have in the system with standards-based interfaces, which I'll show you in a little while, and it was able to generate LCM operations, and in this case, even a testing plan that would go along with the particular function. So in this case, it understands what the elements are going to be in the Open5GS, which will obviously be much different than something like a RAN and so on. It will be able to detect what those are and build a plan around them. As far as onboarding, you can see on the left, those are the kinds of things that we take as artifacts to start. In this case, it was a set of Helm charts in a zip file with a mop, and then the system took that, and the onboarding itself was less than 10 minutes in this kind of a case. If it was a VNF, same exact process, you're just uploading different artifacts to start. If you happen to have something like a Tosca or a Saystar file, you use that as a bootstrap for the system. But basically what you do is you take what's given by the vendor, upload it into the EnterpriseWeb system, it matches it algorithmically with the graph, and basically gives you a minimum viable object as quickly as it can, and it points out any gaps that might be there so you can fill them quickly. Once you've got that.
Bill, I just want to add one point there. When it's a VNF, obviously we can't turn VNFs magically into CNFs. But what we do though is we wrap them in standard operations so that we can manage them like they're CNF. So, again, well, we don't have a magic wand to turn DNFs into CNFs, but we want to have them have more cloud-like capability. So we do that by wrapping the VNF in these standard operations. In this way, we can pretty much manage them similarly to a CNF.
Yeah, and once we've got that workload onboarded, whether it's a VNF or CNF, composing the job tends to be very easy then. We're just selecting out of the catalog, picking a set of relevant tests that we want to run, so test trenches or programs appropriate to that function type, and then any additional parameters. And then the system from there is able to actually compose. And I guess in this kind of a case, there's another step, which is to go to AWS and take a look at the analytics that we've streamed off of there to determine the placement. But basically, once you've composed the test, you're handing it off to the system, and it's very easy at that point. And you'll see that we can even make it easier by using Gen AI to recommend the appropriate tests for the object that you've onboarded. And then, of course, the job itself will be parallelized. So in this case, we will actually walk through a load test and a sanity test, but it could be any number of tests. And again, the system will run them all in parallel, find the optimal workloads, and basically it will save you time and money in this process. So as far as the actual runtime execution goes, that test job is handed off to the system as a simple specification. You're basically pointing at that system under test, so the workload that you want to have tested, the set of test trenches, which will be related to ABOT. The system will then deploy this as a sort of single, if you want, a single transaction. It will basically generate the deployment management plans from a generic template. So it's basically going to look at what you selected there. It's going to recommend and actually discover what resources are available. So that's where we kick in our intelligent meta scheduler, which has been streaming all along the AWS data related to Spot instances across all the different zones, all the different elements that are actually available to us. And then what we'll do is actually evaluate the best fit for the resources available based on cost, availability, etc. It's not limited to a single zone or anything like that. There's really nothing static in this whatsoever. It looks across the entire landscape of what's available in AWS as far as Spot instances, finds the best and most optimal workloads, and then recommends them to you as a user. And then once you've actually confirmed that you're happy with that, it'll instantiate all the instances and deploy the parallelized tests. So there's a lot of detail that you can look at down at the bottom, but basically it will reach into the infrastructure and do whatever's needed to stand up these workloads, including configuring the actual application level behavior that's required for the testing. And in this case, actually configuring Rebaca to run those tests. Then it will effectively do stateful management for the duration of those tests. So in parallel, it's going to be watching those instances and workloads. So if something happens to them, like for instance, the Spot instance does go away, even though we estimated that it wouldn't, it will order another one, migrate the workload. All that's going to be seamless and behind the scenes. So you're not going to be losing any of your testing. Again, it's going to basically handle everything that you might do manually in those kind of cases, and basically make sure that your test is complete. And once they're done, it will report, and it will, in a very nice way, it will actually turn down all the instances, remove them from Spot and all that kind of stuff. So this isn't like a manual Spot job that someone does where they set up policies in advance, monitor them, and then at the end of the day, they have to come in and even clean up after the job's done. In this case, it's going to be full end-to-end life cycle, right from instantiating or even specifying what that job's going to be to completing it and recovering all the resources, so you get basically the most optimized job on every axis.
If I just can step in for quickly.
Yes, sir. Go ahead, Dave.
Okay. Before you go into the demo,
Yeah.
is when we work with telcos and talk to telcos, what we find is, of course, they have testing infrastructure, and of course they use also cloud infrastructure with AWS, and but a lot of those resources are sub-optimized. Right, so even for even within their own tenants and things like that, they have test jobs that are just running and consuming resource longer than they need to. The process to stand things up takes longer. The management requires more oversight, and what we're trying to do is just streamline that whole process. It's 2024. We could do this much more efficiently. We could use models and AI and real-time data to optimize the end-to-end process, and that's what you'll now see in the demo.
Yep. So I'm going to be doing the demo here at AWS. So there's an AWS instance already deployed, as I mentioned at the start. with EnterpriseWeb and the ABOT from Rebaca. You can see here the interface I'm going to use, and I'm going to play the role of a TestOps developer or engineer who's actually going to log into the system and use it to compose and run one of those test jobs. In addition to EnterpriseWeb, as I mentioned before, we have the ABOT test bench, which you'll see me jump back and forth between these two interfaces during the course of the demo. I'll make sure I identify where I am so you don't get lost, but we will be jumping between the two products. So we're going to be going to the EnterpriseWeb networks.ai, going in as a test user here. What I'm presented with, sorry, make sure it's got my right credentials in. So what I'm going to be presented with is an inventory of all of the test jobs that I've already run. So these were the ones that I ran this morning. I can take, obviously go take a look at them. I will go into some of them in a little while, but I'm also presented with a catalog of all the workloads that I might want to test. You can see a couple already onboarded into the system for that description we had at the beginning. I already did this in advance, but it's very easy to add another one. Right now you see there's Open5GS and there's the 5GC, free 5GC. In our catalog itself, we have over 200 telecom objects in the networks.ai catalog at large that you can import, and as long as you have the licenses, you can start using them. So everything from firewalls to advanced network functions, even things like databases and so on. There's a large catalog. All of those really can be available as workloads to test. And then in addition to those tests, the workloads themselves, we have a set of test programs or test trenches, in this case that are mapped from Rebaca for effectively for this demo, but we can again onboard their entire catalog of functions that are going to be across the different types of workloads that you might want to test. So I'm provided with that library of tests, catalog of workloads, and then once I compose them, they'll become test jobs that will execute. So I can pop into any one of these, and I'm going to do that quickly here, just to give you a quick look at what's actually inside here. So that Open5GS, as we mentioned before, this was onboarded from, in this case, it was a zip file that had all of the different, I think it was Helm charts and some mops available. So what the system did was interrogate those artifacts and map them to our standards-based model. So I can actually look at that quickly here, and I'll just take 1 second to sort of pop in and show you, but there is a real graph behind this. If I zoom in out, you'll see some of the elements. What it did was it took that function, and it was able to map it to things like standards-based interfaces coming from 5G, a particular scope, even the components that were going to be identified as the main ones, and then the application models. So it has a notion of a user plane and a control plane so that it can configure those aspects either for use or for testing. So in addition to that, what that gives us is the ability for the system to actually dynamically type this object, autofill the metadata and properties, and wrap it in a bunch of standards-based interfaces. So I can go in and take a look at some of that. So I can take a look at that. This is the class mapping, if you want, or the classification of the object itself. So this is how it was dynamically typed. You can see those application models, for instance, and some of the components. At a metadata level, I can see the properties that were mapped for allowing this to be cloud native itself. I can see if there's custom properties like a host name, and then there's that set of standards-based interfaces. And again, our catalog has all kinds of interfaces from TMF, EdCMF, you name it, that's in there. You can pick out additional ones if you want. These were the ones that seemed most relevant for this function, so they were attached automatically, and they're real live API endpoints, so you can actually even start using them as through a REST interface if you wanted. There's a lot of benefits to onboarding an object into EnterpriseWeb. Now, the focus of this particular demo, though, is testing. So in that context, the system, in addition, as we showed at the beginning, it creates a test plan for this particular object. So what this test plan actually gives you is there's a generic notion of testing as a template, right? And you can see actually if you go left to right here, these stages are pretty much the same for any function that you might want to test. You're going to generate a recommendation as far as where this thing should be placed, how it should be tested, how it should be configured, etc. You're going to instantiate, deploy, actually manage it through the lifecycle, and then of course remove at the end. Now the thing is that from a high level, those stages are pretty much going to be the same no matter what. But since we know the function in the system, it's able to generate a context-specific instance of this process. So we represent that as a state chart, which is what you see right here. It's just a model of an event-driven process. And instead of a flow chart that takes up an entire wall and you're managing very small little micro flows, what you see here are a set of high-level tasks that are effectively going to be chained in an event-driven way. It can go forward or backward between this, and generally it's going to be running kind of top to bottom, left to right. But as you get into things like management, there might be a problem. You might have to move a workload and reclaim it. So any kind of a path that's actually going to be relevant for testing this function will be assembled by the system in real time. And we do this, it gives you a nice way of being able to represent this as sort of, if you want, flow in one screen, right? Like a single pane of glass, I can look at what that process is going to look like from a high level. And if I wanted to, configure the details of any of these, I could drill down into them. I can even simulate this, so I can see what it would look like as a sort of simulation, how it would unfold. And when we talked about how everything is going to be as, effectively as parallelized as possible, that's what you start to see as you walk through this. And of course, for this, you'd be instantiating a control plane and a user plane, etc. I could walk through it more if I wanted, but right now I'll leave it at that. But the important point is that whatever I onboard here, the system will develop this kind of a test plan. And you'll notice there's also one hole in here if you want, or one sort of unspecified element, which is what the actual tests are going to be, right? Which is kind of perfect, right? That's what we want, is for the system to be able to sort of at a high level, whatever that set of tests is, be able to apply them in parallel for me. And again, run this thing as optimally as possible. So that's my onboarded workload in this kind of a case, or function. So what I'm going to do now is I'm going to proceed to actually compose that workload with a couple of tests. And I'm going to use GenAI to help me do that. And you'll notice as I've been walking around the screen, the system is kind of giving me options for what I can say to it to literally, if you want, accelerate events. So all the stuff that I just did manually as I sort of walk through the screen, you can navigate that way in the system, but you can do a lot more interesting things. Like for instance, create a new test job for Open5GC for a small workload. So you can see the system basically bootstrapped it. It went through all those, the catalog of objects, the library of test trenches, attached them together for me, and basically created a simple configuration here. And if there was additional details, they would show up here. I could configure them, or the system, again, would recommend that optimal configuration for the testing. But really, all I had to do was tell the system what I wanted to do for testing. And based on that metadata, the graph, and all the power behind it, it was able to compose this, this test job. And then I can simply go through and I'm going to actually start to create it. Now, before I do that, though, I want to point out, I've said it a couple of times, and David said it at the beginning, that along the way, the system has been actually doing a real-time stream of, I guess it's not telemetry, but of data from AWS with regard to these spot instances, so costs, availability, etc. And we also have all the previous runs of this of our testing suite. So we have historical information we can compare. We have sort of data that we can actually forecast against. So the system in real time, based on all the information that's already been streaming, it's going to give me a recommendation here across all the zones, across a spot, and you could even extend this to being, pure EC2. Like you could have it, right now the metascheduler is focused on spot, but again, could be looking across all the resources in AWS for best placement of these workloads. So what you're going to see now is, so the system made that recommendation for me as soon as I click. What I'm looking at is the set of workloads. You can see, if I look through here, what that system under test is going to be, but it also, of course, had to schedule the particular test. There's a load test and a sanity test. As I go through, of course, it's classifying them, but it's looking at the resource families, so it classifies them into, this is the way that Spot actually identifies them: medium, small, large, etc. And then, of course, there'll be subclasses. It looks across all the regions. It happens that they're all the cheapest in the US East at the moment, which is great. But again, it's looking across the entire spectrum of AWS. It identifies cost per hour and the savings that I get by using these, right? So a 62% savings for my system under test, around 60 or 58, what have you, for my Spot instances. So it identifies those savings, estimates the workload durations. You can see this is going to take about 10 minutes for one of the tests. So we probably are just going to start this and then look at another instance. If time allows, we'll come back to it. But it gives me a pretty good estimate of how long this is going to take. And of course, also the likelihood of survival here is very high for all of these instances. So it meets the threshold requirements for us to actually be able to launch this job. So I'm going to go ahead and do that. Right, so you can see that basically the only work I really did was tell the system what I wanted to do. And it's already started to do unwind and actually run that test. So I can go ahead and, as I start to look at this, it does take a little bit of time to actually complete and run, but we'll at least get it started. You can see it's now deploying. So I get a real-time trace of the actual operations that are gathered. Tests have not started, but you can see it's deploying all the workloads here, waiting for the workloads currently, and this is going to all in real time be updating. So the system's going to be managing this job through its life cycle. Now, rather than wait, as I mentioned before, I'm going to now switch to one that was already completed so that we can see what the system will end up doing at the end of that 10 minutes and what happens sort of along the way. So if I drill into any of these.
And if the new one completes, we'll go back to that.
Yep. So what I can see is that everything from it gathering the analysis at the beginning, and most of these all become like sub-second kind of operations. The 3 workloads were deployed for testing, so a load test, a sanity test. Once the workloads were actually ready, it configured the actual system under test. When it reached a ready state, it initiated 2 tests in Rebaca. You can see the link over to Rebaca. We'll go there in a moment in their ABOT test suite. And then once they were completed, it removed all the workloads, cleaned everything up for us, and gathered and collected or aggregated those tests. So you can see the results here actually are all being displayed at the top. You can see, and again, this scales to however many tests you want. If you want to run 50 tests, that's fine. Rebaca is built for it, so are we. You'll get whatever that set happens to be, and I mean, it's either nice or not convenient for demo, but everything passed, right? If there were failures, it would give you additional details with regard to the failures. But right now, what I can do is actually look and see, okay, there were 270 tests that were run, and I can get a low-level detail of what was pulled back from Rebaca, going through, looking at a scenario, verifying that the AMF supports a particular instance, and I can see at a lower level what all the details might be from what was pulled back from Rebaca. And the other nice thing is, of course, I have the links that I can go right to Rebaca itself and take a look at the details if I want to. So we'll just go in quickly to their test bench. We'll take a look, but what I can see is, okay, here's our 5GS epic that was built, was being tested. I can see what those particular tests are. Here's a September 11th test. And I can see, what passed, what failed in a nice little sort of UI-based way. I can even view the analytics based on that. Sorry, they're not enabled here. But what I can do is drill into the test itself, and again, see more and more details of what happened. And I can drill down to whatever lower level I might want, including even having things like recommendations that the system is going to be able to generate. In this case, since everything passed, there's no recommendations available, but on things like a failure, it will even help me to recommend things like a reconfiguration, which can then flow back into EnterpriseWeb so we can do some closed loop and so on. Let's take one quick look here and see if maybe our test's actually completed. No, they're still ongoing. Let's just take a quick look, but you can see they're being scheduled here. The results are pending, and at the end, maybe we'll even come back to it later if we have some time after the Q&A to see the completed results. But that's the end of the demo. Thank you very much, and let's switch things back to Dave.
Fantastic. That was great, Bill. Thanks. I hope that was clear for everybody who attended. And essentially, we showed how the power of a sort of model-driven, AI-powered platform essentially optimize the end-to-end testing process and sort of provide an abstraction over this highly volatile spot instance environment so that you can scale out your operations. The spot instances on their own would be difficult. You could obviously do them manually, but the abstraction makes it easy for somebody like a telco who doesn't do 1, 2, 5 tests, but might want to be running hundreds or maybe thousands of tests, and you're doing that continuously. You want to be able to make this systematic, and that's the whole point of what we're doing today. So, Graham, I wasn't able to pay attention to the questions. I don't know if questions came in during the call, but let me know if you've got any, and we're happy to discuss.
Okay. Well, I've got a couple of questions that came in previously, so let me just go through that and just remind everybody that they're welcome to ask questions now if they'd like to, either in the chat box or by raising their hand in the participants tab. So feel free to do that at any time, guys. We got a few more minutes, 20 more minutes left. We're okay for time. So let's have a look at this. Jenna from C-Spire. Thank you for the demo and the cost and savings showing from tests is impressive. What are our execs and engineering teams? Okay, she made a statement here, I guess, or Janet, yeah. So the comment here is that the execs and the engineering teams are looking for these kind of cost and savings. I mean, do you want to make any comments on that, Dave? Seems like it's all good news to me.
It's all good news. I mean, I think so much of what telcos are looking for in general regarding AI is greater intelligence for better automation, right? And so it's all about ultimately about OpEx. It's all about productivity, ease of use. Um, and, it's also about keeping the focus on what the telco wants to do, not like on all the technical detail. I think at some level, the technology is getting away from people, right? There's almost analysis paralysis. There's so many LLMs to consider. There's so many things. People don't understand necessarily the relationships between graphs and LLMs and analytics. This is complex stuff, but it's also not necessarily core to the telco business. It's core to enabling telco business. So what we're trying to do is sort of tamp down sort of the scary parts, right? Just make the AI pervasive in the background. Let everything be sort of this new era of being model driven, so telcos can just get the benefit. Because I think that's what the comment is really about. Is execs, this is what you wanted. This is what you're looking for. Is you want to take advantage of these things. So for demonstrable ROI, right? And that's actually been so far even a bit hard with AI to show that demonstrable ROI. Here's a great use case that shows it's like low hanging fruit. Let's do this. Let's save resources. Let's save energy. This is something that can be done immediately. And test cases for telcos is really an optimal use case for Spot.
Great. Okay. Hey, thanks, Dave, and thanks, Jana, for your comments. Appreciated. Deepak's got a good comment, good question here. Should he think of this as a model that provides a product owner greater control over feature testing without getting into the massive DevSecOps? So over to you, Dave.
Yeah. So no, that's exactly what it is, Deepak. It's essentially making it catalog driven, right? That's probably the best way to distill it for a telco. Is saying, hey, you've got your, like Bill mentioned, we have about 200 plus telco specific objects in our catalog already, and we have about 100 plus sort of general IT. So 300-400 items in our catalog that probably cover a lot of what a telco uses. But of course, telcos can onboard anything, any of their partners, what they work with. We make onboarding really easy, and they can sort of streamline that testing process. Because I think part of the challenge that Deepak is sort of pointing out too, Graham, is that this whole move towards like Open RAN, putting pressure on open multi-vendor networking, and obviously there's a lot of initiatives. People sort of want to bust out of their silos. They want to onboard innovation faster. They want to take advantage of more competition to lower prices, get capabilities. Well, that just puts the burden on testing, makes it so much higher. And so telcos need to make these processes easier, right? And it becomes scalability. It becomes about scalability. If you have to do this manually, right? I think in some ways, I think even developers and engineers want to get away from some of this stuff, right? All this point-to-point integration, that's not the sexy part of their job. It's not the fun part of their job. And when you do everything point-to-point and everything glue code and manual integration, it actually slows down processes. It makes things opaque. It makes things hard to analyze. It makes it hard to automate, and it makes it hard to use AI. So by doing this on an all model-driven way, you sort of liberate your data and optimize your processes.
Okay. Hey, thanks, Dave. Bill, I think this is a yes, but the question is also, did you use voice to prompt for the test creation that you were doing?
Yes, I did.
Yeah. Okay.
Yeah.
So Jana, that's a simple question answered. If you have any more, feel free to throw them at these guys. They'll be happy to take them.
I'll elaborate a little bit, just because essentially we're using Gen AI in a very the problem with Gen AI is sort of funny. If everybody remembers that MWC 23, nobody was talking about Gen AI. A couple of months later, everybody was talking about Gen AI, right? And at one point, we thought there would be just one model to rule them all. And now, of course, there's big models, small models, open source models, domain-centric models. And immediately, that should make people start thinking in a classic way. It's like, hey, wait, these are just other elements that need to be managed. And I need to work with multiple models. I might use different models for different purposes. Maybe for cost, maybe for security, maybe for IP concerns, right? There's open source, whatever. They're going to use a variety of different models. I need those all under management. But importantly, Gen AI has some very powerful capabilities, but it also introduces some concerns. So you need to isolate and contain Gen AI, right? You need to treat it in a classic architecture approach, right? It has a blast radius. We don't want anything to do with Gen AI to do anything to our mission critical automation. So we encapsulate it, we contain it, And we use it in a very targeted way. So in the beginning of the call, I mentioned that it's just Mixtral out of the box. We didn't train it, we didn't tune it. We're using essentially our graph model, which is a really sort of rich domain knowledge about telco. And we're using that with KX because KX is a vector native database. So KX is helping us translate between our graph, which you would call symbolic language, into the vector language that the LLM speaks. And we're able to speak very precisely. It's like a very concise conversation. So it's even less prompts and less tokens because we want to keep down that expense, keep down that resource consumption, keep down that energy consumption. So yeah, in this case, primarily we're demonstrating a Gen AI NLP interface, but we're deployed in a tier 1 telco in North America that's using it for essentially code support or code summarization. They're using us with an open source model on premise. So we can use Gen AI very flexibly for various different purposes.
Okay. Hey, there's a couple of more comments, questions here that I've got for you, Dave and Bill. The first one, the Telia in Scandinavia and over in the new Baltic countries. And the question from Telia is interested in network testing and in brackets plan build before handover to operations run. Is that something that means anything to you in terms of where you're coming from here?
Yeah, and I think it's essentially, so I appreciate the question. So essentially before, we focused on the sort of execution side, right? Sort of very rapid, like onboard it, compose it, deploy it, run it, done. But as the attendee, I'm sorry, I don't see that list of who's asking the questions, but as the person asked, this is usually in telecom, there's a planning process for pretty much anything, right, or everything prior to it even touching somebody who's actually going to physically manage it or virtually manage it. So so I think that's a great question, and yes, we can support the planning process as well because, and in a way, we make that richer, right? Because we can sort of bridge that real time. We have the historical data, we have the data from what we're actually executing. We can push that continuously into testing. We don't necessarily have that interface today, if I'm just being honest, but we could feed those interfaces, and then those interfaces can invoke EnterpriseWeb, right? So we could support, let's say, a seamless handoff between planning and execution. Hopefully that's a fair.
Okay. Okay, thanks. So, Michael from Intel, where are your LLM mixtral and vector models KX running? On the local laptop or one of the pre-configured instances?
So that's a great question. So Bill actually runs mixtral local on his laptop, on his Mac, and in this case everything's deployed into AWS. But yeah, we're supporting LLMs, open source LLMs deployed on premise for telcos. As well as cloud. We collaborated with Microsoft. So in 2023, at MWC 23, we met with Microsoft executives, and in May 23, we demonstrated with GPT 3.5, I believe, the world's first telco-grade Gen AI for service orchestration. So obviously AWS has great with Bedrock and everything else like that. They have LLM management, et cetera, and a variety of LLMs offerings. Gen AI offerings. For our telco customers, we have to be able to flexible to support whatever their partners are, whether that be cloud partner.
Jan has just commented here, a question mark, AWS Q, Bedrock.
Yes, yeah, absolutely. It's essentially, we can think of it this way, Janice, we can onboard LLMs like we onboard XNFs. In EnterpriseWeb, because we're model driven, we essentially treat everything as a typed object. So you literally say, I want to onboard an LLM. The system knows what an LLM is, at a high level is conceptually. And so it can relate to it contextually. That's when in the demo you saw Bill, the system goes in, sort of types it automatically, starts auto-filling standard metadata, auto-filling interfaces based on that sort of knowledge of the domain and knowledge of the
Okay.
not just the telco domain, but also the systems
Okay, so I've got another couple of comments here.
This is great. I appreciate all the questions.
So this particular one, I'm not sure what they mean in here, but this is from Alex in Canada. Hypergraph for telco operations, and there's no question mark. That's a statement. I'm not sure what he means.
I'm going to assume there's a ... or a question mark. So, so the hypergraph. So, and we didn't go into full detail about that. We talked about the telecom ontology, but we didn't go into full detail just because we wanted to focus on the use case here today, on testing. But if I were to step back and essentially think of it this way: telecom has a ton of standards. No one of those standards dictates the whole end-to-end. So what do telcos do? They actually pick and choose different versions selectively, pick and choose standards from different standards bodies that they want to deploy, specific versions of those that they want to deploy. And then they tightly couple that all together into a model, usually a hierarchical model, and then they import their own, wrap that or customize it with their own concepts. And the problem for that is that becomes really tightly coupled. Sort of a big ball of mud. Anybody that knows the TMF SID knows exactly what I'm talking about when I talk about big ball of mud. And the problem with that is, look at the rate of change, look at the rate of innovation. You can't keep up with things anymore. So a hypergraph, or just a graph, is just a more flexible, extensible, and adaptable way to model data, period. Graphs are just, it's known in computer science, it's known in software engineering, that graphs are just a better way to model complex relationships between elements. A telco is a graph of people, information, and capabilities. A network service is a graph of functions, environments, and other components, right? They call it a service topology, right? That service topology is a graph, right? The network is understood to be a graph, right? Because these things have credit. So it's best if you could just don't model them in a hierarchy, model them as a graph. Traditionally, that's been pretty hard to do. Most people who use graphs, using most graph databases are databases. They're meant for people who want to do data analytics, data recommendations, data science, but they're not meant for real-time intelligent automations. And real-time intelligence automations raise the bar on graph, because you not only need to know about entities and data entities in the relationships, you need to know about behavior. You need to know about infrastructure. You need to know about devices. You need to know their current state and telemetry. And you need to be able to compute that at millisecond speed to do that LCM that you actually demonstrated on today's call. So a hypergraph is actually a type of graph. So it's beyond, if you know Tiger Graph, if you know Neo4j or Semantic Web. Those are all forms of graph databases, right? They also have some challenges when they scale. I think some telcos have experimented with that and have run into problems. EnterpriseWeb uses our own implementation with 22 awarded patents on our implementation of hypergraph. A hypergraph, sort of like the name suggests, supports complex multi-dimensional relationships and even conditional relationships. Like, these two things only relate to each other on these circumstances based on events. So essentially, our graph supports the use of events and policies to interpret relationships so that we can reason over a network or over a service topology, look at all the different elements of a service individually and collectively, the slice, service, functions, the RAN, the core, the transport, and actually do our analysis using AI and analytics, then to take the best actions and generate mitigation plans to manage those. So that's a long-winded response to hypergraph. What is it? But I hope that's helpful. And of course, we have a lot of demos on YouTube. I have my own channel, Dave Dugal, on YouTube, and if you go to it, there's actually plenty of demos that go in depth on that. And of course, we're happy to talk to anyone about.
Hey, Dave, thanks. Listen, I've got a couple of questions here that are quite interrelated, I think. So the first question, how does this compare to existing FinOps tools? And then also a similar question, if you like, to understand the differentiation between AI compared to sophisticated tools that do data-intensive correlation techniques to come up with proposal solutions which are represented in a human language. So a lot of words there, But you know, how does this compare?
Okay, so I'll start with the first, and then I'll go into the second. The first one's a little bit easier. So FinOps has been around for a long time, and because essentially almost since the birth of the cloud, people realize like, how do I optimize that? Right? I'm gonna, I'm migrating all these workloads to this cloud. This cloud stuff's pretty expensive, and this is a great instance of where AWS is actually proactively looking to make its resources, lower cost of resources available to its customers, so that they can optimize their spend. So the notion of optimizing spend is FinOps, financial operations. It's cloud resource management. You want to call it that, right? The problem is that's mostly been done, actually, going back to the previous question, it's mostly used for planning, to be honest, right? It's a data-driven planning and analysis, and it's mostly used for the more static VMs and cloud-native tenants and things like that people utilize. But the problem with this existing tools, like, and even Amazon has, or Amazon partnered with us for this, Amazon has Spot Fleet, which gives you some capabilities over your Spot instances. But the problem is, for most things, is this is way too dynamic and volatile an environment for existing FinOps tools that were meant for something that was a little bit more slower moving and planning on a longer term basis. How do I reduce my resource spend for the quarter, or for the year, or for the month, or the week? And what we're doing is we're optimizing for the load, right? Like per instance, per load, on the fly. So that's one of the big distinctions. The other one is that most of the cases, even though there are FinOps tools, to the extent that they're supporting deployment of test jobs, it's all manual integration. So you're back to that. You're not going to get this nice, fun, sort of easy talk to the network, compose your service, deploy, and walk away, right? Zero touch everything. The third thing, and this is sort of critical, and I think telcos will recognize it, is everybody in the cloud world and everybody in the telco world are guilty, of a bit of a myopia, in the sense that you guys are all infrastructure bound, and your whole history is based on infrastructure. So telcos think about infrastructure first, right? The cloud providers think about infrastructure first. But the problem is, everything that's interesting in 2024 today is at the application layer. It's at the service layer. It's about AI and how do I optimize customer experiences, developer experiences, outcomes, business outcomes. How do I, you don't do that down at layer 1, 2, 3, 4. Those are enabling layers for the workloads that run on top, which actually move at level 7. And so in most existing tools, they don't support really application with the static configuration. And what you're seeing here today is we're showing how we can do everything dynamically. If we have to if we see something faulting, right? There's actually in Spot instances, there's this notion of if the SLA, if your Spot instance, if the time for that availability for that Spot instance is running out, you can get evicted with like 30 seconds notice or something like that. And also that workload just gone. EnterpriseWeb is tracking the state of all, so let's say we deployed 100 instances of that test across different Spot instances, and we see some of them are starting to fail or time out or whatever it is. We're tracking the state, asynchronous cloud native way. We're tracking that state. We see that problem come up. We take those workloads, we either restart them or we actually find other Spot instances and restart them based on last known state. And we continue running that job, right? Because that's the way to make sure that it's most efficient, right? And do that all zero touch, right? So that answers part one of how do we compare to FinOps tools, right? There are tools that have been around for a while. People are free to look that up. I mean, I think everybody in telco knows what FinOps is. And I think telcos are very, very in tune with their spend on telco, on cloud, and wanting to optimize it. Again, our friends at AWS came to us saying, it's like, we literally specifically, they came to us saying, we really want to do something cool with you here because we want to help telcos. We think testing is a great use case for Spot instances. We want to help our telco customers save money. So they didn't pay me to say this. It's a POC. I didn't get paid. I didn't get paid for anything here. But that literally was the motivation, to the extent that, believe it or not, hyperscalers can have good motivations. They want you to get the most for the least from the resources. So that's one. I think the second part of that question was, can you refresh that? It was AI. It was like it was essentially like a hybrid AI question.
Yeah.
So the answer, the answer is that we're using all of the above, right? We're literally in this demo, we're using, because we think it's a fallacy. Making Gen AI the center of your architecture is a huge mistake. First of all, these LLMs change way too fast. Tightly coupling to an LLM is a mistake, right? Because even a specific type of LLM or vendor implementation of LLM, they're versioning very fast. So you don't want to tightly couple. And then, of course, LLMs are very competitive, right? So you want to be able to actually evolve with this industry, which is rapidly changing, and work with the LLM that supports certain use cases most optimally at the lowest cost with greatest efficiency, greatest security, and all those things like that. And that book is not written yet, right? This is going to continue to be wrapped. So you want to be able to be flexible over Gen AI. Then it's really important to note is Gen AI is great at some things, maybe unsurpassed in some tasks that really nothing else does, like really particularly brute force tasks, like document summarization, things like that. Things that like are time consuming, tedious, and error prone, even for humans. So actually, it's a great thing to outsource Gen AI. However, there's certain things it does suboptimally, and some things it doesn't do at all, like it doesn't do predictive analytics by itself. It doesn't have a historical state generally, right? So, so you really want a mix of Gen AI, which is a form of deep learning, classic AI and algorithms, and as well as for AI ML workloads, as well as analytics and rules, right? Because there are things that AI algorithms, analytics, and good old-fashioned rules do faster, cheaper, better than any Gen AI will. And so I go back to that point about architecture and just good old practices of software architecture is use the best tool for the job. In this demo, you didn't see it, but EnterpriseWeb is actually calling on Gen AI to do this, it's calling on analytics to do that, it's calling on algorithms to do this. It's doing it all in the background to satisfy that customer experience.
Okay.
Right? Nobody has actually programmed that part in EnterpriseWeb, it's just doing it.
Hey, Dave, we're just about out of time, but could you just give us a quick comment on other use cases beyond testing?
Well, so you essentially want workloads that are, because of the nature of these ephemeral, you want use cases because of the nature of these ephemeral spot and reserved instances. They need to be fault tolerant because the availability is not guaranteed. Right? There's no SLA on this. It's not just going to run until your job completes necessarily. We'll give you the prediction based on history, and that will be actually quite good. But we need to be able to have durable, resilient workloads. In general, spot and reserved instance utilization is made for cloud native functions because cloud native functions inherently are stateless and they should be, and so that makes them already fault tolerant, and so it makes them easy to move around. As I mentioned earlier in the call, we wrap VNFs because the reality is telcos are still using a lot of VNFs and PNF too. And so we wrap those VNFs with operations. So even in this circumstance, we can still move them, scale them. We can handle them like they're cloud native. It doesn't get the impact of them being cloud native. Those things have to be done by those vendors. But as far as operationally, we're allowing those tests to be performed with a VNF almost identically to a CNF. Characteristics will be different, right? But operationally, we're going to enable that automation. So I think that's pretty cool for a telco. So you want workloads that are cloud native or cloud native-like. They need to be fault tolerant and resilient. Test is great because tests are inherently ephemeral. But other ones would be like high performance computing. If you have high performance computing workloads that are relatively short-lived, awesome, right? That's great. We can distribute them, run them across a lot of computers, and bring back results. Analytics, same thing. You have some analytics workloads or web service-based workloads. They're short-lived is sort of key here to all these kind of things because you don't have the guarantee. You want shorter-lived workloads, but shorter-lived workloads that are being managed so that you're, it's not like you're just running into traffic, right, and dodging cars, right? We're giving you that abstraction over the top. That's what that telecom ontology does to sort of smooth out those bumps, different instances coming and going. So analytics, high performance computing, short-lived AI workloads, and testing, web services. If you need a scale out for those things. So all of this would apply equally to those workloads as they would. But TestOps is just a great, it really might be the sort of optimal one, specifically for telco, because it's low-hanging fruit. They're under pressure. They got to do more testing. They got to do it more efficiently. And they, of course, would love to see.
Excellent. Hey, Dave, Bill, really thank you very much. We're just about out of time. We're a few minutes over. So really appreciate your time today. Thanks very much. Very insightful, as always. Bill, great demo. Thank you.
I just want a quick shout out to my friends, Bhuval Day and Krishna.
I was going to say, any last comments? Go on.
A quick shout out to our friends at AWS, Bhuval and Krishna, as well as the Rebaca team, Samir, Kuntal, Debayan, and Suchi, and our good friend Andy Churchill at KX. So, need to give credit where credit is due. And thanks everybody. This was, I think, the most lively Q&A we've ever had. We've done, this is our fourth one with IWPC, and this was a great session. So I really appreciate all the questions. I'm glad people were engaged. So thanks everybody.
Hey, no, thank you very much. Thanks everybody for joining. Really appreciate it, and hope to see you again sometime. And as I mentioned before, don't forget, if we're in Austin, Texas in October, come over and have a look what AT&T are doing with the old evolution to 5G. Hey, thanks.